Hello? Test 1, 2, 1. Okay, it's day 2, 14 o'clock, and now we have a talk about Batman, the not quite well-known, but soon-to-be well-known protocol for especially the Freifunk community. And the talk will be about how to bring the routing from layer 2 down to layer 2. I'm sorry, I mixed it up. Up from layer 3 down to layer 2, and well, give a welcome to Marek Lindner from Berlin and Simon Wunderlich from Chemnitz.
Thank you and welcome to our talk. I will first give a short outline. We will introduce to you, maybe you don't know what the routing protocol is, so we will explain and what is different in Batman. But we won't talk about Batman here, we will talk about how to go down the layers from layer 3 to layer 2, and we will talk about the problems which got solved automatically and the new problems, and we will show you how we brought this into kernel space.
Well, first of all, we should... Can you hear me? I'm not sure. Yes? Okay. First of all, some background about what we are talking about. Usually, we have the idea to build a wireless network somewhere in a city or in a rural area, and you have a couple of devices you can see, and the green ranges show the range of each device, and the green little bubbles show the interaction between the devices, so data is passing from one device to another. But the usual geek who wants to create such a network faces two major problems we want to outline here. First is the Wi-Fi layer. The Wi-Fi layer is a bit tricky. You cannot see it, you cannot touch it, it is there, and it is interacting with a lot of other devices and a lot of other interferences. And so we have an example scenario which could be 6 o'clock in the morning. You have some WRTs which form the backbone of your wireless network. These are the blue little machines. You have some notebooks connected to these WRTs, and then you have some cell phones with Bluetooth, and they disturb the signal, or you have some microwaves, they also disturb the signal, or you have foreign networks which disturb the signal. So what is the problem here? The problem is you cannot configure it. There is no config file for the Wi-Fi layer. It's just there, it's invisible, and the geek has to leave the notebook aside and has to climb onto roofs and build antennas, and that's usually a big problem. But so the geeks come to us and say, oh, we have a nice protocol. Would be very nice if your protocol could solve the problem and I can stay in front of my computer. And our protocol has to solve these issues. And if we go to the next slide, we see that in the evening the network looks much different, because some devices were switched off and other devices were switched on. And again, our protocol has to manage all this. And now comes the second major problem for geeks, which is, you can go to the next slide, is the geek itself, because the geek itself will create a complex network. We have VPN connections, we have ad hoc networks, we have infrastructure networks, all connected and all should talk, and it's an endless way of configuring and bringing all these nodes together. And you can see down there is maybe a LAN, and up there where the Ethernet is shown, we have maybe a big church, and then you have some internet points, gateways which offer internet connection. And during the time I'm involved in the Freifunk network, I thought after the first year, oh, now I know all the setups, and all the time new people coming up and say, oh, I have a new idea and make it more complicated. And so it's endless, the configurations I've seen. And all that should be handled by a routing protocol. Well, you can do all this manually. You can just configure your routing tables. But you will find out that this is quite a task to do, because it's changing all the time and everybody has ideas how to improve it, how to make it better. So you want a way to do this automatically. And here is what the routing protocols do. You have some kind of software and you start it on all the nodes, and then they talk to one another and find the best ways to route your traffic. This is just the basic idea. I know that some people here are quite familiar with routing protocols and others are not. So we don't go too much into detail. We just imagine that we have some kind of software which should manage all this stuff, so all this complex configuration and the Wi-Fi layer. And there are common approaches, link state routing or other source routing, but we came up with another solution because, well, as a usual geek, we said we can do it better. So we have a new approach we call it Batman. And of course, we have an interesting name for it. It's an abbreviation, Batman, Better Approach to Mobile Ad Hoc Networks. Of course, we are the best. What is the difference? The main difference between other approaches is that we don't calculate all the ways between all the nodes, or we don't, we just say, we are here, every node says, hello, I'm here, and all the other nodes see, oh, there's a node somewhere, and everybody keeps in mind, where is my best neighbor towards this direction? That's basically the idea of Batman. I know there are some people in here who would like to discuss all the fancy routing stuff. I suggest that you join us later and we can have all the big discussions about link state routing or this routing or other routing, but we want to talk about kernel stuff, we want to talk about layer stuff, so we don't go into much detail here. Just keep in mind, we designed this protocol for wireless networks. It means our protocol wants to have a lossy network. Our protocol needs packet loss. Otherwise, it won't work so good. And the major advantage of our protocol is that we do not have a single node which knows the whole topology of the network. In fact, we spread the information about the whole network over the whole network. Every node knows a bit about the network. So it's a bit about what we heard about Erlang here. We spread the information to reduce the cost on every node. But as I said, we just assume there's some magic doing all this fancy stuff, and we think it works. Or you can find out by yourself. But we go now into another part of the routing stuff, and yeah.
Okay. First, we look how does a routing protocol daemon works now. This is for Batman, but I think every classical routing daemon works like this. We have the brown part is what this daemon manages, and the blue part is what the kernel manages. So you see the daemon only exchanges routing information, for example, on some UDP port, and sets the routing tables. So payload traffic is routed by the kernel. So if a packet comes in, the kernel looks onto it and sees the routing tables, and I have to forward it on this device to this neighbor. So we don't have to manage this. We only set routing tables. And of course, these are IP routing tables, so it only works with IPs. We could also use this for IP version 6 or something else, but things like DHCP or other protocols don't work. And administrators have to make sure that everyone has a unique IP. So, or you have IP collisions, and this will, of course, not work. And if you have fancy network setups, like we have seen before, you have your local network and maybe an access point in your home, and you want it all to be routed through the whole city, you have to make some effort and have to announce this, set your routes manually. And this is one thing which can be solved with our approach.
Let me add one important point here, which is basically we have a chicken and egg problem in a mesh network, because you want to join the network. For joining the network, you need an IP. But how do you get the IP? Usually there is some kind of central server who has the knowledge about all the used IP and used IPs and the unused IPs. So you need internet access. So you need to join the network. So you're back again in the first step. This is a major problem we face, because we have a lot of people who really don't have internet access, and they only can get internet access if they join the network. So the basic problem here is that we need this central instance which can give you an IP or some kind of configuration before you can join the network. And this is one of the major problems, because next to the problem I just mentioned, every city, for example in Germany and or German Freifunk networks, makes it different. I mean, in Germany, in Berlin, we have a big web server where you can click your IP. In other parts of Germany, everybody makes it different. So if you move from one city to another city and you want to join the mesh network, again, you have to find out how they handle the IP business, and then you have to configure your IP, and then you can join the network. And that is a major problem in this approach here.
There was a question, no?
Oh yeah, if you have a question. Yeah. Wait a second.
Wouldn't IP version 6 auto-configure solve this problem with IP addresses? Would it? Could it?
This is a longer discussion.
Okay, sorry.
Yes and no. It is more complicated. I don't want to go into the deep steps of IP version 6. There are some ideas, but it is not perfect. I mean, that depends. Let's talk about it later, okay? If we have enough question time, then let's discuss the IP version 6 issue. Okay? There's another question.
There is some approach in IPv version 4 that is auto IP, that it asks for ARP about if somebody has his proposed IP and then he gets this IP. You know what I'm asking? Auto IP.
If we have auto IP configuration.
Yeah, to get some IP. It's a private IP, but should work maybe.
I did not understand. Can you speak a bit louder? That's the main problem here.
There are approach that it's auto IP, that it's for getting an IP in a network.
Automatically, you mean?
Yes. This doesn't solve even?
Well, what approach do you mean? I know that some people at olsr.org work on auto configuration IP issues, but all the approaches I've seen up to now are not perfect. They still have glitches. They still have, problems left and the right side. And usually in a practical network, you have these glitches more often than the usual case, or you have more trouble with them. So I've not seen any auto IP configuration which works very good. But I don't know everything. So if you have a good solution, maybe we talk later. The main problem is that the routing daemon itself needs an IP, because the routing daemon will send out a packet and writes in the packet, this is my IP address. I am here. So